In this video, we'll know how to compute the inverse of a 3 by 3 matrix. In this example, let A equal to this matrix here, 3 rows and 3 columns, which is the size here 3 by 3, and here B equal to this matrix, which is 3 by 3 matrix, 3 rows, and here 3 columns. Find, if possible, A inverse and B inverse. So here we have two questions. Find A inverse, then the second one, find B inverse. So if it's possible, so it means that maybe A or B, they don't have inverse. So we have to keep it in our mind that it might be no inverse for this matrix or this matrix. Before to start to solve this problem, let's quickly review the definition and the method to find the inverse of a matrix. Let's go up now. So here we have here to find the inverse of a matrix. Here in this method, we want to solve it by RREF, Reduced Row Echelon Form. So if you have here A, in our example here, if you have this A here, or B, or any matrix, to find A inverse here, we have this steps. So if you can transform A to identity matrix by reduced row echelon form, which means that you use elementary row operation, row switching, row addition, and row multiplication to transform A to identity. So if you can transform it, then on the right hand side here, so this identity, it will transform to A inverse. And the same thing here, if you put this here, A inverse on the left, and you put here identity, if you do RREF, which is reduced row echelon form, then if you can transform this A inverse, which is here, that's why I put it in the second line, not here, because I switch them here. If you can transform A inverse to identity, then you will back to here, which is A. So just to remind yourself, if you have A, if you can transform it to identity, then A inverse on the right hand side. But if you cannot transform A to identity, like here I put, if you cannot transform A to identity, then A inverse does not exist. So here I put here note to illustrate what I mean here. So if you can transform A to identity, then A inverse exists. And the same thing, because here I put if and only if condition. If they told you A inverse exists, then you have to know that you can transform A to identity matrix by reduced row echelon form. And the same thing here, if you have A inverse does not exist, then you have to know that A, you cannot transform it to identity matrix. And of course, this is another note here, which is related to here. If A is not a square matrix, then A inverse does not exist. A square matrix, it means that this matrix, it has to be the size 2 by 2, 3 by 3, 4 by 4, and so on. So it has to be a square matrix to find A inverse. If it's not square matrix, then A inverse does not exist. And here I wrote the definition here. The matrix A, which is n by n, which is here square matrix. This mean here square matrix, square matrix. The matrix A, n by n, is non-singular, or they called it invertible, if and only if, the same as the symbol, there exists a matrix A inverse such that, So the matrix A n by n is non-singular, or they called it invertible, if and only if there exists a matrix A inverse such that A multiplied by this A inverse equal A inverse multiplied by A equal identity. So if you have any matrix multiply by another matrix which you called it A inverse equal, if you change the order here, if you put here A inverse multiplied by A equal to identity, then you have to say this is its inverse, and you can say that A is non-singular or invertible. To illustrate this definition, let's read this note, which explain more about this definition. Maybe you cannot understand this definition, then you can understand this. So A inverse exists, then A is non-singular, or they called it invertible. If A is non-singular invertible, if they told you it's given that A is non-singular or invertible, then you have to know A inverse exists. So if it is non-singular A, then you have to know A inverse exists. Then you can apply this definition here. If you multiply A by its inverse, you have to get identity matrix. And the same thing here. If you have A inverse does not exist, then you have to say A is singular or not invertible. And if they told you A is singular or not invertible, you have to know that A inverse does not exist. Maybe you think it's hard to understand this one, but it's very simple logical behind this. It's like multiply a number by its reciprocal. So if you have, for example, if you have 5, multiply by its reciprocal, which is 1 over 5, you will get 1. The same idea here. So if you have, for example, here A multiply by A inverse, then you have to get identity matrix. And here I put here n because the identity matrix of size n is the n by n matrix with ones on the main diagonal, 0 elsewhere. So just to illustrate this, if you have identity equal 2, it means that 1, 0, 0, 1. And the same thing if you have I3, it's mean a square matrix, which is 3 by 3. Here 1, 0, 0, 0, 1, 0, 0, 0, 1. So this 3 by 3 matrix, and here you have 2 by 2 matrix. So the definition of the identity matrix of size n or size 3 is the n by n matrix with ones on the main diagonal, 0 elsewhere. So, and if I put here n, it's mean here this A, it's n by n, and here the inverse is n by n, which is square matrix. To illustrate this more, why I make it logical with this thing, because the determinant of identity, so if we take the determinant of identity, you will get 1. So that's why I wrote this, because I want to print this in our mind and to make it logical about the concept behind this definition. So now I want to write here, remember, if you have any matrix, I will write it like this, multiply by its inverse, like here, multiply by its inverse, it has to be equal to identity with size n, here n by n, here n by n. And the same thing here, if I change this order, if I write this one, then this one, equal to identity, the same thing. The same thing as here, if you write 1 over 5 multiply by 5, it's the same it's equal to 1. Here, the same idea here, exactly the same idea. And of course, if you multiply 5 multiply by 1, you will get 5. So here the same thing. If you have any matrix, multiply by identity. Of course, it has to be square matrix. Then you will get this matrix. The same thing, if you have 1 multiplied by 5, you will get 5. The same thing. Here it's like 1 multiply by any matrix, which it has to be square matrix. Then you will get the same matrix here. Just I want to change the color, so you have to remember this to keep it in your mind. Just I want to make it logical with this. So now you understand how to connect this thing with this thing. So just I want to illustrate more to print it in our mind. To find A inverse, we have to follow this. So A, we have to transform to identity. If we cannot transform A to identity, if we have, for example, a 0 row in any row of this matrix by applying RREF, then we have to conclude that A inverse does not exist. It's like here. If you cannot transform it, then you have to say that A inverse does not exist. We will see this down. So now let's solve this one. Now let's solve this A inverse. A, then here I have to write identity matrix with size 3, because here 3 by 3 equal. Now let's copy this one. Now let's put here line, which is this one. Then I have to write identity, which is 1 0 0 0 1 0 0 0 1. Now to start to solve this one by reduced row echelon form, the easy way to put this, the third row, in the first column, because here just we have to multiply by -1, and here we have 0, so we don't have to do anything. But if you want to solve it here by dividing this row by 7, here it will be fraction, which is very hard to do RREF for a matrix because you will get a lot of fraction here. So the easy way to put this row here, or of course this row here, but I prefer this because here you have 0 as well. So now just I want to switch this row with this row. So R3, I want to switch it with R1. I will speed it up, so I will write this one here and this one here, and I will put on the middle here the same because I will not change anything here. Now I want to write this one here because I will not change anything in this row. Now I want to multiply this row by -1 because RREF here, it's like a stair or a snake. It's like a stair from up to down, so you have to walk until you find number, then you have to make it 1. Then if you make it 1, then you have to make every number below this leading one, we called it leading one or a pivot. Then you have to make this one 0, then this one 0. Then if you make this one 1, then if you go down, then if you walk until you find number, if you find number, then you have to make it 1. Then if you make it 1, the rest of this column has to be 0. then if you make it the rest of this column 0, if you go down, then if you walk until you find number, if you find number, then you have to make it 1, then if you make it 1, the rest of this column has to be 0. So it's like this RREF, and you have to keep in your mind, so this matrix, it has to be identity. You have to start from here, then it has to be here 1 1 1, and the rest elsewhere is 0. So now just multiply this row by -1. So negative row 1 in row 1. So here it will be 1 0 -1 0 0 -1, because I am multiplying this row by -1. So here 1 0 -1 0 0 -1. These two rows remains the same, so I will speed it up to write them here. So now here we have leading 1. Here we have to make the rest of this column 0. So to make this one 0, we have to add this one with this one. So -1 plus 1, it will be 0. And here to make this one 0, we have to subtract this row by this row. So we have, and multiply this by 7. So 7 minus, it has to be here 7, which is here it will be 0. So first this row, let's change the color. So row 2 plus row 1 in row 2, because -1 plus 1, which is 0. And here row 3 minus 7 minus, it has to be here 7, which is here 7. I will multiply this by 7 in row 1 in row 3. This row remains the same. I'll speed it up. Now row 2 plus row 1. So row 2 here -1 plus 1, which is 0. 1 plus 0, which is 1. 0 plus -1, which is -1. 0 plus 0, which is 0. 1 plus 0, which is 1. 0 plus -1, which is -1. Now row 3, here row 3 minus, so this number minus 7 multiplied by 1, which is 7. So 7 minus 7, which is 0. -3 minus 7 multiplied by 0, which is 0. So it will be here -3. -3 minus 7 multiplied by -1. So let's write it here. So -3 minus 7 multiplied by -1, which is -3 plus, because negative with negative, it will be plus 7 equal 4. So here 4. Row 3 here 1 minus 7 multiplies 0, which is 0. So it will be the same here 1. 0 minus 7 multiplied by 0, which is 0. So 0 minus 0, which is 0. 0 minus 7 multiplied by -1, which is like here 0 minus 7 multiplied by -1, which is 7. So now here we have here leading one, and here we have leading one. Now we have to make this one 0. So to make this one 0, we have to make -3 plus 3. So we have multiplied this row by 3. So row 3 plus 3 multiplied by row 2. So row 3 plus 3 multiplied by row 2 in row 3, because -3 plus 3 multiplied by 1, which is 3, so it will be -3 plus 3, which is here, it will be 0. So these two rows remains the same, so I'll speed it up. Now 0 plus 3 multiplied by 0, which is 0, so 0 plus 0, it will be 0. -3 plus 3 multiplied by 1, which is 3, so -3 plus here it will be 3, it will be 0. Now 4 plus 3 multiplied by -1, let's write it here. 4 plus 3 multiplied by -1 equals, so 4 minus 3, which is 1. So here we have to write 1. 1 plus 3 multiplied by 0, which is 0, so 1 plus 0, it will be 1. 0 plus 3 multiplied by 1, which is 3. 7 plus 3 multiplied by -1, which is 4. Let's write it here. 7 plus 3 multiplied by -1, here -1, it will be 7 minus 3, which is 4. 4. Now here we have leading one, leading one, leading one. We have to make the rest of this column equal to 0. So let's write it here. So if we add this row by this row, so -1 plus 1, it will be here 0. -1 plus 1, here it will be 0. So row 1 plus row 3 in row 1, and row 2 plus row 3 in row 2. The third row, it remains the same, so I will speed it up here. So now row 1 plus row 3, here row 1 plus row 3 in row 1, so 1 plus 0, which is 1, 0 plus 0, which is 0, -1 plus 1, which is 0, 0 plus 1, which is 1, 0 plus 3, which is 3, -1 plus 4, which is 3. We will add row 2 with row 3 in row 2. So 0 plus 0, which is 0, 1 plus 0, which is 1, -1 plus 1, which is 0, 0 plus 1, which is 1, 1 plus 3, which is 4, -1 plus 4 equal 3. Now here we have identity matrix. So I will write it like this. Here we have identity matrix and the line here, and here we will get the A inverse. That's it here. So here we have A inverse here on this side, on the right hand side, and here we have identity matrix. I will write here this identity here matrix, you can see. So here in this side we have A inverse. Then A inverse equal 133, 143, 134. That's it here. We find the inverse of this A. So just I want to illustrate this one more. This is A, this is identity matrix. Then we transform this A to identity matrix. Then we get here the A inverse. Now let's confirm that this A inverse is indeed the inverse of this A. So let's go down a little bit. We have already finished. Just I want to confirm our solution. Just I want to put here line to make sure that we have already finished to solve this, but I want to confirm our solution. To confirm, A inverse is the inverse of A. To confirm our solution here, just we have to apply this definition. A multiplied by A inverse, it has to be identity matrix. So A multiplied by A inverse, it has to be identity matrix. So this is A here. I will copy this one here. So I'll speed it up. Now I will copy this one here because this is A inverse here. So I'll speed it up. To find this element, we have to multiply this row by this column. Let's write it here. So 7 multiplied by 1 plus -3 multiplied by 1 plus -3 multiplied by 1 equal, here it will be 7 plus, or -3, it will be here, -3, and here -3. Then we get 1. So here we have to put here 1. To get the second element here, we have to multiply this row by this column. The same thing, I will write it here. So 7 multiplied by 3 plus -3 multiplied by 4 plus -3 multiplied by 3 equal 7 multiplied by 3, which is 21. -3 multiplied by 4, which is -12. -3 multiplied by 3, which is -9, equal, so here I will write it 21 the same, -12 minus 9, which is -21. 21 minus 21, which is 0. So here I have to write 0. 0. To find the third here, the third element, we have to multiply this row by this column. I'll write it here. So 7 multiplied by 3 plus negative 3 multiplied by 3 plus negative 3 multiplied by 4 equal 7 multiplied by 3, which is 21, negative 3 multiplied by 3, which is negative 9, negative 3 multiplied by 4, which is negative 12, equal, I will write here the same, 21, negative 9, minus 12, which is minus 21, which is 0. So I will write here 0, 0. The second row here, with the first column to find this element. So negative 1 multiplied by 1, 1 multiplied by 1, plus 1 multiplied by 1, plus 0 multiplied by 1 equal negative 1 multiplied by 1, which is negative 1, plus 1, 0 multiplied by 1, which is 0, equal negative 1 plus 1, which is 0, plus 0 equal 0. So I will write here 0. To find this element, we have to multiply this row by this column. So negative 1 multiplied by 3 plus 1 multiplied by 4 plus 0 multiplied by 3 equal negative 1 multiplied by 3, which is negative 3, plus 1 multiplied by 4, which is 4, 0 multiplied by 3, which is 0, equal, so negative 3 plus 4, which is 1, plus 0, which is this one, equal to 1. So here 1. Now this row by this column to find this element. So negative 1 multiplied by 3 plus 1 multiplied by 3 plus 0 multiplied by 4 equal negative 1 multiplied by 3, which is negative 3, plus 3, because 1 multiplied by 3, plus 0 equal negative 3 plus 3, which is 0, plus 0 equals 0. So I will write here 0, 0. To find this element, we have to multiply this row by this column. So negative 1 multiplied by 1 plus 0 multiplied by 1 plus 1 multiplied by 1 equal negative 1 multiplied by 1, which is negative 1, plus 0 multiplied by 1, which is 0, so plus 0, 1 multiplied by 1, which is 1, so plus 1, equal, now negative 1 plus 1, which is 0, plus 0, which is 0, 0. To find this element, we have to multiply this row by this column. Negative 1 multiplied by 3 plus 0 multiplied by 4 plus 1 multiplied by 3 equal negative 1 multiplied by 3, which is negative 3, 0 multiplied by 4, which is 0, so plus 0, 1 multiplied by 3, which is 3, equal -3 with 3, which is 0, plus 0, which is 0. So I will write here 0, 0. Now this row by this column to find this element. So -1 multiplied by 3 plus 0 multiplied by 3 plus 1 multiplied by 4 equal -1 multiplied by 3, which is -3, 0 multiplied by 3, which is 0, so plus 0, 1 multiplied by 4, which is 4, equal -3 plus 4, which is 1, plus 0, which is 1. So I will write here 1. So here 1. As you can see here, you have identity here, which is 3 by 3, which is, it's like a magic. You multiply these two matrix, you will get identity matrix. So we confirm that this A inverse is indeed the inverse of A, because we multiply them together, we get identity matrix. The same way, you can multiply A inverse multiplied by A, you will get the same identity matrix. So we have applied this rule, which is the same as I wrote here. Remember that any matrix multiplied by its inverse, it's equal to identity matrix. Now we confirm that A inverse is indeed the inverse of A. Now let's copy this matrix. So we will find the B inverse now. Now we want to solve number 2. We want to find B inverse. So we write here B, and here we put line, and here we put 3 because B is 3 by 3 matrix. Now I will paste B. So we have here B. Now I will put line here, then I will put here the identity 1 0 0 0 1 0 0 0 1. Let's change the color. Now we have already here 1, so we have to make the rest of this column 0. So 1 minus 1, it will be here 0, so we have just subtract these two rows. And here we have 5 minus, here it has to be 5, so we have to multiply this row by 5. So row 2, this row 2, 1 minus 1 it has to be, so row 2 minus row 1 in row 2, and the third row it has to be minus, and here we have to multiply by 5. 5 row 1 in row 3. I will speed it up to write this row here. Now here 1 minus 1, which is 0, -2 minus 2, which is -4, 1 minus -3, 1 minus -3, which is 1 plus 3, which is 4, so I will write here 4. 0 minus 1, which is -1, 1 minus 0, which is the same 1, 0 minus 0, which is 0. Now 5 minus 5 multiplied by 1, which is 5. So 5 minus 5, which is 0. 0. So here negative 2 minus 5 multiplied by 2. Let's write it here. So negative 2 minus 5 multiplied by 2, which is negative 2 minus 10, which is negative 12. So here negative 12. Negative 3 minus 5 multiplied by negative 3. So negative 3 minus 5 multiplied by negative 3 equal, which is here negative 3 minus with negative, it will be positive. 5 multiplied by 3, which is 15, equal 12. So here 12. 0 minus 5 multiplied by 1, which is negative 5. So 0 minus 5 multiplied by 1, which is negative 5. Negative 5. 0 minus 5 multiplied by 0, it means 0 minus 0, which is 0. 1 minus 5 multiplied by 0, which is here 0, so it will be 1 minus 0, which is the same as here 1. So here we have here leading one, and here we have to make this one leading one by divide this row by negative 4. But before that, since we can see here this row, it's almost the same as this row in this side. If we divide this row by 3, then it will be negative 4, which is the same as this, and this one, if we divide this row by 3, it will be the same. So here it will be 4, and here 4, 0, 0. So if we subtract this row by this row, then we will get a 0 row on this side, which means that we cannot transform this side to identity matrix. Since we know that here we will get here a 0 row, therefore we will divide this row by 12 to make it easier for us to subtract them after the next step. So just I will divide this one by negative 4, and I will divide this row by 12 to make it easier for us to subtract this row by this row. And we don't need to make these two elements 0 because we will have a 0 row. So now let's write it here. So I will divide this row by negative 4. So 1 over 4, negative 4, I will divide it in row 2, here, and here I will divide it by 12. As I said, you can do step by step, but finally we will get the same answer. So you can do as usual, but I will make it shorter to solve this problem. So now I will speed it up to write this row here. Now 0 divided by negative 4, which is 0. Negative 4 divided by negative 4, which is 1. 4 divided by negative 4, which is negative 1. Negative 1 divided by negative 4, which is 1 over 4. 1 divided by negative 4, which is negative 1 over 4. 0 divided by negative 4, which is 0. Here we will divide this row by 12. 0 divided by 12, which is 0. Negative 12 divided by 12, which is negative 1. 12 divided by 12, which is 1. Negative 5 divided by 12, which is negative 5 over 12. 0 divided by 12, which is 0. 1 divided by 12, which is 1 over 12. So here we have leading one, here we have leading one. So now we will add this row by this row, then we will get here 0, and here we will get 0, then we will get 0 row in this side, which means that B inverse does not exist. So row 3 plus row 2 in row 3, I will write these 2 row the same here. I will speed it up. So here 0 plus 0, which is 0, because we are at this row, the third row, with the second row in row 3. Negative 1 plus 1, which is 0. 1 plus negative 1, which is 0. Now here we don't need to compute these things, but I will compute them. Negative 5 over 12 plus 1 over 4. Let's write it here. Negative 5 over 12 plus, I will multiply here 3 and here 3. So it will be 3 over 12, which is negative 5 plus 3, which is negative 2 over 12, which means that if we divide here by 2 and here by 2, then it will be 1 over 6. So here it will be negative 1 over 6. Negative 1 over 6. 0 plus negative 1 over 4, so it will be negative 1 over 4. 1 over 12 plus 0, it will be 1 over 12. Now I will let this one equal to C. I will write it in this way. So I will call this one C, and I will call this one D. So this matrix is equal to C, and this matrix equal to D, this matrix here. So I will write here since C, which is this part, has a row of zeros, we stop and conclude that B inverse does not exist. So we conclude that B inverse does not exist. Since here we have a 0 row, so we conclude that we cannot transform B to identity. Therefore, in this side, we will not get B inverse. So sometime we cannot find the inverse of a matrix. Now we have finished. We have find the inverse of A, but we cannot find the inverse of B. So we find this A, the inverse of A, but we cannot find the inverse of B. As you can see here, it's very simple way to find the inverse, but of course it's better to find the inverse by using the computer to find the inverse of a matrix. But it's very important concept because you can solve a linear system by using the inverse of the coefficient of the linear system. In the next video we'll do 4 by 4, but then we will do a lot of problem which is solving a linear system by using the inverse and a lot of application of the inverse of a matrix. But sometime in the future we will use alternative method to find the inverse of a matrix by adjugate, or they called it adjoint, in some time in the future. See you in the next video.